Hello everybody, welcome in my office. This is the place where I've been working all weeks and last months on the MOOC, and which has been attracted a lot of attention, and I was very happy to see that during the first week there's been a lot of activities. There is rocks here, you don't see them, there is books, there is maps, typical office of a geologist. Now, starting from this week, I will give every week a feedback clip. I will record this clip addressing some issues which I think are particularly important. If you want me to address other issues or specific things, don't hesitate to ask me. Now, the first issue which I want to talk about is accommodation space. And we define accommodation space as the space, the vertical column of the space in which sediments can be deposited. If you see in this picture, for instance, sediments produced in the mountains, they're transported in the rivers, and they will deposit it there where we have accommodation space. In the case of Northern Europe, illustrated here, there is little accommodation space in Switzerland, little accommodation space in Germany, and there is the accommodation space which is left in the North Sea. We have defined the accommodation space as the water column, the distance between the sea level and the sea floor. In this case will be, for instance, 10 meters. If nothing changes, then only 10 meters of sediments can be deposited, because once this accommodation space is filled, then the sediments must be transported somewhere else. Now, this is obviously not a realistic situation if you consider that we have sedimentary successions up to kilometers thick. Now, how do we increase accommodation space? One way to do it is to increase sea level. This is what happens when the ice caps melt down. This is what's happening now, and the sea level rises. But this is maximum 100, 200, 300 meters, and therefore it does not really help us. The big important way to increase accommodation space is to let the basement subside and create more and more accommodation space. The next very important issue is the lithosphere. Keep in mind definitions, they are very important. We've defined the lithosphere as the rigid body overlying the low velocity zone. The low velocity zone is an area where, because of temperatures, the rocks have a bit of melt between the grains. In terms of composition, the rocks of the low velocity zones are the same as those of the lithospheric mantle. It's simply that these are just a bit molten, and therefore the boundary between the lithosphere and the asthenosphere is a thermal boundary. Second important thing, remember that the lithosphere is composed of two layers, the crust and the lithospheric mantle, separated by the moho. So the moho is a boundary between different kinds of rocks, whereas the boundary between the lithospheric mantle and asthenosphere is a thermal boundary. The last issue which I want to mention to you is plate tectonics. This is the picture which I've been showing, and the picture which you see all over the places. I have been cheating to you because this is not really a good plate tectonic picture. This is characterized by the fact that things never change. We see here mantle coming up, the lithosphere subducts and keeps on rotating. Things are not born, they don't become older, and they never die, exactly like Mickey Mouse. In reality, there is a couple of features which clearly document that this picture does not work. One is shown here, and this is the East African rift, the rift which is now starting from the Afar Triangle, going down through Kenya and Tanzania and Mozambique. And the second one is a section through the Alps with continental collision. These two features are the proof that the Mickey Mouse plate tectonics does not work. And I will leave to you to think about possible explanations, and we can discuss about this in a second time. I wish you a pleasant, productive and strong second week of the MOOC, and we will come back to you in a week's time.